Good afternoon. Let's look at page 70, questions 3 through 5. Now the first thing we want to do, we have to match up this equation with one of the graphs that is in the book. So if we look at this, we can factor this part of the equation. So we can say y is less than or equal to x plus 3 and x plus 1. Because the 1's will multiply together to give 3, and my inside and outside terms will give 4. So now I know that my roots are at negative 3, and that here it's at a negative 1. So we know that in our graph we're going to have a root at negative 3 and negative 1. So let's start graphing that part. So if I think of a table of values, I have x and y. I have my negative 3 and a negative 1. And that means that my y value is 0 at both of those. Let's find our vertex point. If I take a negative 3 plus a negative 1 and divide by 2, that's going to give me a negative 4 divided by 2, which gives me a negative 2. So let's plug our negative 2 back to the original function, just so we can figure out what our value is. So a negative 2 squared plus 4 times a negative 2 plus 3. So that's going to give me 4 minus 8 plus 3. So 4 minus 8 plus 3 is going to give me a negative 1. So I'll put that there. So let's put our points that we have so far. I'm going to go over to negative 1. We know we have a point there. Negative 2, negative 3, and we have a point there at our roots, and then at a negative 2, negative 1. Because we have a equal part, this is going to be solid. It's a solid going up. So let's look at the options that we have. The only one that is option that has a solid line on it is C, and so we know that it's shaded outside. So C is our answer. Let's look at the next example. Here we have y is greater than a negative x squared plus 4x minus 3. Now the thing here is that I would really like to get rid of that negative that's out in front. So I'm going to factor it out. X squared minus 4x plus 3. So I have to change all three of those signs. So now let's factor this. X minus 3, x minus 1. So we know that we're going to have two roots at x equals 3, and then we have another root at, I was wrong, I'm going to add 1 to both sides. That'll give me x equals 1. So in my table I know that I have two roots, one at 3, 0, and one at 1, 0. So let's find our vertex between it. Well, 3 plus 1 is going to give us 4 over 2, which will give us 4, divided by 2, which is 2. And if we plug a 2 back into our original function, I'm actually going to plug it into this part. Take a negative 2 minus 3 times 2 minus 1. Doesn't matter which one you plug it into, but this one's easier for me. 2 minus 1 is going to give me a negative 1. And then 2 minus 1 is going to give me 1. So if I multiply that together, it gives me a positive 1. So now let's look at our graph. We have value 1, 0, 2, 1, and at 3, 0. So this one's opening down, and it's a dashed line. And it's dashed because this is not equal. So if we look at the options for that, the only one that opens down is A, and that's shaded on the outside. So our answer is A for that question. Let's look at our next example. Here, we just want to factor this. X minus 3, x minus 1. So we're going to have roots at these two values. We're going to add 3 to both sides. We're going to add 1 to both sides. So we have factors at 3 and 1. And again, the average between that is going to give us 2. We know that's going to be 0 and that's going to be 0. So let's plug that 2 back into that equation. 2 minus 3, 2 minus 1. So that's going to give me a negative 1. And that's going to give me a positive 1. So that's going to give me a negative 1 value when I multiply that together. So if we graph that, we're going to go 1, 0, 2, 3, 0, and then 2, negative 1. It's not equal, so it has a dashed line. If that is not equal, it becomes dashed. And if we look at that, there's only one option that actually opens up with a dashed line, so we know it's going to be the one that's shaded outside, which is B. Have a great day. Bye-bye.